Okay, so now members are going to go into details of a lampshade. They are going to give us this question. They are going to ask us to get the height, the slanting side of that cone. Now, some questions they are going to be giving just the lampshade, then it's up to you to generate that cone. But now, because we are just starting, I'm going to give you, and when I'm also showing you how that cone is. So this is the question. The figure below shows a lampshade ABC bounded by circles of radii 15 and 25 centimeters. The slanting side AB is 30 centimeters. Was cut from cone OA BCD. This was the cone where the lampshade was cut. Calculate the length of that and then the angle DOA. Now, you see that now this cone here, if I want to get this, we are going to use similarity. Now, if I pick out this triangle here and I put it here, I think you see, if I remove this triangle here, the whole of it, and I put it here, that's the shape I'm going to be having. Now it's that I can easily get this slanting side OA. How are you going to get OA? Of course, if I call this OA, let OA be L. So that now, if I get this as my L, it means that now the big slanting, this one here, is going to be now L plus 30, the whole of this up here, if I try to do that. Now it's that if this is L, this is going to be L plus 30. Now there I'm going to simplify. So that here I have one unknown. Now this triangle here is similar to this triangle, a small triangle there. Now, if I use similarity, so similarity, using this similarity, you see that now we say we are going to say the big radius over small radius equaling to the big slanting over the small slanting. Or some people, you just, even if you say big height, big radius over big slanting, it's up to you. Everything is going to work. So the big radius, this is now the big radius. We use similarity if two things are similar. Now, so that this triangle here is similar to this triangle here, just that it's just the shape, but they are similar in shape. There you can use similarity. So now, the big radius, for the big triangle, the radius is 25. Over the small radius, now for this small triangle is 15. Equaling to the big slanting from here up to here is L plus 30 over the small slanting. The small slanting is here, which is just L. As simple as that's all there you have used similarity. Thereafter, we are going to cross multiply. When I cross multiply here, I get 25 L equaling to, this times this you get 15 L, then plus 15 times this you get 450. Now there we make L the subject by taking this side. You'll be having now 10L equaling to 450. So that now your L, if you divide it by 10, is 45 centimeters. Meaning that now, therefore, our OA, this length OA, is 45 centimeters. And that's it. Now, they want us also to get the angle DOA. So this was reminding me of one. When I come to remind me of two, where they want me to get the angle DOA. Where is DOA? The angle DOA. So it's the angle. Now, if I extract out this triangle here, allow me to extract this triangle here. If I'm going to use this triangle out, like if I extract out that DOA. Now, you see that if I draw a line perpendicular there, This one is going to be my 5 centimeters. I mean 15 centimeters. Now I have this already. Now my OA is here as 45 centimeters. So now if this is theta, then also this one is going to be theta. So now I just need to get one theta, then I multiply it, I'll be able to the whole of that. So now, to get this angle, what do we have? We have the opposite and then the hypotenuse. There you can use now sine. So my sine theta is going to be the opposite, which is 15, over the hypotenuse, which is 45. And so it's that our theta there, you're going to get so here I'm getting 19.47 degrees. And now, if that is the theta, now it's that our angle D of A is going to be 2 theta, which is going to be, I multiply this by 2, I'm going to get 19.47 by 2, I get that 8.94 degrees. And so I have got that angle there. Then the height of the lampshade. Now how am I going to get the height of the lampshade? If the height of the lampshade, this is the height here, they want us to get of this lampshade here. Now, if I come and draw that thing there, so you see that here I have my 25 centimeters. Here I have my 15 centimeters. Then this slanting here is 30. And then OA, where it is 45. Now from here up to here, down, so that if you add those two, if you add this plus this, I think it's that you get 75 centimeters. Now, if I call, okay, it's so that I can easily get this height. If I call this height capital H, and I call this just small h, the height from here. So now the big height, the whole over there, is going to be now h plus that small h. Now I want to get the small height. Now, to get the small height, of course from here, you see if I have this and I have this, I can get this h. Now let me pick out this triangle here. So if I peel out this triangle, the small triangle there, so that now, whether this is N, this is B, and this is our N. So if I pick up this triangle, A, O, so this is my H, this is 15 centimeters, and this is 45. First of all, I can get this. How am I going to get this? Using Pythagoras. So, H squared plus 15 squared is equal to 45 squared. So now my H is going to be the square root of 45 squared minus 15 squared. And so my height is going to be, press that on the calculator. So when I press this on the calculator, I get 42.4264 centimeters. So this is this height here. But I want the height of this lampshade because my lampshade, this is its height. So now it's that if I use this similarity, I can get the whole of this. So if I use similarity, I can get this. How am I going to use it? So see that now, using similarity. Okay, let me use here. Using similarity. So if I use similarity, now this is going to be the big height over the small heights over the whole of this over this. We want to get just that h. Now, if I want this h, also I can get this height. So if this height, I can get this ON is going to be equal to this and then that. So using, here let us say, using now the triangle ONB, using triangle ONB, is that now this height or n squared is going to be, this or n squared plus 25 squared will be equal to 275 squared. Using this is going to be the side, then plus this is equal to the longest side. So here it's that our n is going to be the square root of 75 squared minus 25 squared. And our n is going to be, then you get your calculator there, 75 squared minus 25 squared, root answer. So here I'm getting 70.7107 centimeters. So that is my ON. Now, if I have ON, so that now my h plus h is equal to ON. So if that is the case, allow me to first remove this one. If you want, you can use that also that singularity. Now, so that my h here I had it, so that my h is going to be ON minus capital H. But I have calculated already. So it is going to be 64, and so my height is here. We just get that and subtract the 2. So the answer I'm getting is 28.2843 centimeters. And therefore, the height of the rock shape is this. So that's Roman numeral 3. Roman numeral 3. That's the height of the rock shape. We have to go through all that. Then when we come to volume of the cone, as Roman numeral 4, our volume of the cone is always a third pi r squared h. This is going to be a third. We don't have pi, then times the radius. So now our radius of this cone is 25. So 25 squared, then times the height. So that we have got the height as ON. So our ON is the height, which is 70.7107. And now this is going to give you 0.71. So here I'm getting 14,731.39585, and this is cubic centimeters. So members, that's how we had to check out that number, and that's all. We are going to now have more examples about the first one. I wish you the best.